Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. In this lesson, we're going to learn about segment partitioning. Specifically, we're going to learn about how to find a point that partitions a segment with graphing, and then with coordinates, and then how to determine the partitioning ratio. So let's talk about what all that means. Imagine I am at my house and I have to walk to school. And let's say I live straight down Rhode Island, so it's a straight shot from my house to the school. And your friend says, hey, I'll pick you up about 2/3 of the way down. Okay, so they're going to pick you up right here. We've got from our house to the school. This is 1/3 of the way. This is 2/3 of the way. And they said they're going to pick you up 2/3 of the way. Okay, we are going to find out what that point is when we're looking at a graph and decide what that coordinate would be. And that's really the most simple way I can think of this lesson. Okay, so segment partitioning means simply a segment is, we know, a line that has two endpoints. And to partition means to break into parts. So this line has been broken into 3 different parts. And that's what it means to partition a segment. Partition means just to break up. All right, back on our class example, we're at home. We're going to meet up 2/3 of the way. Now we want to understand that 2/3 of the way can also be thought of as a 2-to-1 ratio. So this line, this segment from our house to the school is broken into 3 parts. Part 1, Part 2, Part 3. So this indicator here is 2/3 of the way, 2 out of 3. But you can also name that as a ratio, a 2-to-1 ratio. So in other words, 2 parts here to 1 part here. So if you're talking about a ratio, you're talking about a 2-to-1 ratio. Or if you're talking about a distance, 2/3 of the way, 2 out of 3 parts to get you 2/3 of the way from your house to school. And another thing to note is that when we're talking about segment partitioning, we're talking about directed line segments. From A to B is considered, it would be listed like this, AB. So the letter that comes first is where you start, and the letter that comes second is where you end. And so a directed line segment, the direction is important, because think about it, 2/3 of the way from school to my house, well, that would be right here, right? So it's a different point. 2/3 of the way from my house to school is right here. So it makes a difference, the direction that you're given in your problem, if you're going from your house to the school or from your school to the house. Okay, here now we're going to look at converting a ratio to a fraction. So some problems would say find the point that's 2/3 of the distance from A to B, and another problem may say find the point that partitions it in a 2-to-1 ratio. So what you'll notice on all these examples is that the top number is always the same, whether you're in a fraction or a ratio. But then a ratio is like 2 parts out of a total of 3. So like we already noticed, this is 2 parts, this is 1 part. And so all together you have 3 parts. Let's take a look at another example. So this segment is partitioned into 4 parts. And so this right here is 1/4 of the way. So 1 out of 4 is the fraction that would represent 1/4 of the total distance. But then as far as ratios, it is split up in a 1 part to 3 part ratio. So going back and forth, let's say you were only given that it's a 1 to 3 ratio, but you needed the fraction for what we have to calculate. Well, you can always just add these parts up, 1 part here and 3 parts there, and that would always give you the bottom number of your fraction. Or if you have the fraction and you need to go to a ratio, well, you've used 1 part here. There's a total of 4, so you need to subtract that 1 from the 4, and that would get you a 1 to 3 ratio. So 4 minus 1 would give you this number here. Let's do another example. 3/5 of the total distance versus a 3 to 2 ratio. So again, if I'm going from a ratio to a fraction, I'm going to add these up. That gives me the bottom number there. If I got the fraction 3/5, I'm going to say 5 minus 3. It gives me a 3 to 2 ratio. All right, sometimes these problems would be on a graph, and you may get lucky and it all works out where I can just kind of count it out. So in this problem, I'm going to look, I've gone from P down to Q. So that means I traveled some amount in the Y direction, that much in the Y direction, and this much in the X direction. Well, okay, a ratio of 1 to 3. So let's think about how many parts that is. A 1 to 3 ratio, let's draw it real quick. 1, 1, 2, 3. So a 1 to 3 ratio would be this point here. That means I've got a total of 4 parts. So I'm going to add these together, and I've got a 1/4 of the way. So here I've got 1, and then 2, 3, 4. So this one, a 1 to 3 ratio. We put my point right here, 1/4 of the way. Now, going to follow that over and find out where it hits this line right here. So this would be the point that partitions this in a 1 to 3 ratio. Now we could calculate the Y value. We could count just from the graph. We could see the Y value is 5, but the X value is not right on the grid. So we would have to do some calculations there to figure out if we wanted that actual coordinate. So let's talk about real quick how we would do that. So the X values are going from 1, the distance from 1 to 7. Well, how far is from 1 to 7? 7 minus 1 is 6. Okay. Well, so we traveled 6, and we want to know 1/4 of the way. So 6 times 1/4 of the way. Well, that is 6/4. And reduce that fraction, and you've got 3/2. So that's 1.5. So I'm going to start here, and I got to go 1.5 to get to the X coordinate. So that would put me at 2.5 or 2.5. And that would be the point that partitions that. Now a little bit bigger problem here. You could put this on a graph, but sometimes it's not always practical to be able to put something on a graph. We need to actually calculate what we're doing here. But let's go ahead and first we're going to find the partitioning point between these two that puts it in a 5 to 2 ratio. So we'll just kind of draw a picture to start with. I like to always draw a picture. So I'm going to say, okay, I've got A is at -3, 1, and I've got B at 4, 8. Okay, so from A to B, we want to partition this in a 5:2 ratio. So 5 parts here and 2 parts there. All right, so the next step I need to do is find the length of this segment. Well, again, if we put this on a graph, it's traveling in the x direction and in the y direction. So let's kind of just give a little visual of what that would be over here. So 1, 2, 3, 1. That's your A point, and 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, something like that. And somewhere in here is the point we're looking for. We're going from A to B. Okay, so we're going to see what our x length is. So the x length is going from -3 to 4. Now here's where you want to always make sure you go directional. So we want to take the second x, 4, minus the first x for the distance between A to B. If you were on a graph, you could just count that, but we're going to do 4 minus a -3, and that gave us 7. Now on this particular problem, the y is going to be the same length. So we went from 1 to 8, so I'm going to calculate 8 minus 1, and that's going to give me 7. Okay, so we traveled 7 in the x direction and 7 in the y direction. Now my next step is to turn that ratio into a fraction. So we are looking at a 5:2 ratio. So that is the same as a 5/7 of the total distance. Okay. Now I'm going to come down here. I'm going to multiply the length of the x distance traveled. So the distance traveled for x was 7. And I want 5/7 of that length. So 7 over 7 is 1, and that becomes 5. And because our numbers are the same, y is going to end up being the same. We traveled 7 for y, and 5/7 of that distance is 5. Okay. Now my last step is, now I know I've traveled 5 in x and the y direction, but I need to know the actual coordinate. So I got to start with my coordinate -3, 1, and then I traveled 5 in the x direction and 5 in the y direction. So now my new coordinate is, I went from -3 up 5, so that put me at 2. I went from 1 to 5, that put me at 6. So the actual point that's going to partition this in a 5:2 ratio is 2, 6. So your answers on these things will always be in ordered pair. You're looking for a point on the graph. So my little hand-drawn graph over here, over 2, up 1, 2, 3, 4, 5. And so somewhere around here would be the point P. All right, different kind of problem. We just want to find the partitioning ratio, and for something that's already there. So this, since this point is on the coordinate, I can simply go, so we're going from N to M, that's our direction, so I need to go this way. I went down 1, 2, 3, 4, got me down to here, and this point is right here. So that is a 1:3 ratio for x, and the ratio should be the same for x and for y, but we'll just look at that. So here and that was the y direction, my bad, sorry. On the x direction, we went from 0 to 1, that's where we lined up at. Then 1, 2, 3 more, 3 here, 1 there. So that is again a 1:3 ratio for the x direction. What we've accomplished, hopefully, is to partition a segment with using graphing. Sometimes you can just count it out, sometimes you might have to calculate it. and using coordinates, and then determining the ratio by just counting the grid. All right, we'll see you in class.